Hello everyone, welcome to our channel Knowledge of. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with the classes that is of chemistry for class 12, and that is this has been the class that you have is your class of 15 we have, and we had completed your 14 classes, where in that classes we had completed your unit 1 and the unit 2, unit 3, unit 4 as well, and even though we have started with unit 5th, and hopefully if it is not exceeded more than hours, so yes, we'll surely complete that soon in this class only. So unit 5 surface chemistry, we have discussed about half of the unit in the last classes. So first of all, it's a huge request from my side to all the viewers to please go through with the subscribe button and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. In terms of it, today we're gonna start with your first topic, and that is the preparations of colloids. Preparation of colloids. In terms of preparations of colloids, here there are a few important methods for the preparations of colloid that could be are as follows. The first we'll discuss here, which is your chemical method. In terms of chemical method here, that the colloidal solution that can be prepared by chemical reaction that leading to the formations of molecules by double decomposition, oxidation, reductions or hydrolysis. These molecules then aggregate, leading to the formations of salts as well. Where the reactions for this we have here, there are many reactions that we have to discuss in terms of chemical methods only, and that there are, so we'll discuss some of them, which is the first equation we have here is AS2O3 plus 3H2S in the presence of, that is the double decomposition that has been taking place. That will give here is AS2S3, which is in sol, plus 3H2O that we have. Okay, so here this is arsenium sulfate and this is arsenium oxide here, and arsenium oxide here as well. So let's go ahead with another equation that we have is your SO2 plus 2H2S, and that will give, this is the oxidation takes place in the presence, that is 3S sol plus 2H2O here, that is the colloidal solution that we make by the arsenic here. Another equation we have is 2AuCl3 plus 3HCHO plus 3H2O, and that is, it will give here, it is that is the reduction. Then we'll get 2Au sol plus 3HCOOH plus 6HCl here. Another we have here is FeCl3 plus 3H2O in the presence of hydrolysis. The hydrolysis takes place, it will give FeOH thrice sol that we have, and then it is plus 3HCl here that we have as an answer, and these were the reactions for this as well. So here the second we'll talk about it, which is your electrical that is disintegrations or the Brady's arc method here that we have to discuss here as well. On the same cases we'll go ahead and that is we have to discuss about it, which is electrical disintegrations, that as I told you. So for the same sake we have, that is the electrical disintegration. or Brady's arc method that we have. So in this process involves the dispersions as well as the condensation that colloidal salts of metals such as gold, silver, platinum, etc., and that can be prepared here. On the same behalf of it, we will be going ahead further, which we have to even go talk about it. On the same cases, in reference towards this, that we have to go ahead, and by this method we can say that in this method the electrical arc is struck that between the electrodes of the metals that emerged on the dispersions medium. Example like the intense heat produced vaporizes the metal, and which then condenses to form the particles of colloidal as well. Now we'll talk about the third one, which is your peptization, and that peptization we can say that. So we'll go ahead for that. But before it, we have to understood about the Brady's arc method as well. So that I will just draw a diagram for it. This is a beaker here. Okay, so this is here, this has been the ice bath. Here it is. This is ice bath. This is your dispersion medium. This is electrodes. So this is your Brady's arc method. In this we'll talk about the third one, which is the peptization. The third is your peptization. In that same case, the peptization may be defined as the process of converting a precipitate into the colloidal salt by shaking it with the dispersion medium in the presence of a small amount of electrolyte as well. And in the same case, that the electrolyte used for this purpose is called peptizing agent, and this method is applied generally to convert the freshly prepared precipitate into the colloidal salts, where in the same case during the peptization the precipitate absorbs one of the ions of the electrolyte on its surfaces, and this causes the development of the positive or the negative charge on precipitates, and which ultimately break up into the small particles of the size of the colloids as well, where absorb is when only absorbed or the surfaces here. Now we'll talk about the another topic that we have to discuss here in the same cases, that is the purification of the colloidal solution as well. So that we have to go ahead. Purification of colloidal solution here. In the purification of colloidal solution, where the colloidal solution when prepared generally contain the excessive amount of electrolytes and some other soluble impurities, while the presence that traces of electrolyte is essential for the stability of the colloidal solution. Larger quantities coagulate it, and therefore the necessary, that is to reduce the concentration of these soluble impurities to a requisite, that is the minimum process that is used for reducing the amount of the impurities to the requesting minimum is known as the purification of colloidal solution. Purification of colloidal solution is carried out by the following ways. The first we'll talk about is their dialysis. In terms of dialysis here, it is a process of removing a dissolved substance from a colloidal solution by imaging or meaning of the diffusions through the suitable we have membrane. And since the particles, ions or smaller molecules, a true solution that can pass through the membrane, that is bladder and a parchment paper, cellophane as sheet, but not the colloidal particle that the membrane that can be used for dialysis. Apparatus that used for this purposes is called your dialysis here, where a bag of suitable membrane that contained the colloids solution is suspended in the vessels through which the fresh is continuously flowing here, and which is the molecules of the ions then diffuse through the membrane into the outer water, and pure colloidal solutions are left behind. So for that we'll be going ahead for a diagram that you can understood better in easy way here. Dialyzing membrane, this is your water plus crystalloid. This is here in this inside it, which is your salt particles, and this is another, this space we have is your crystalloid, which is, you can say, the electrolyte. Here it is pumped as is your water here, that is pumping it out. This is what the process is known as dialysis. Now we'll go ahead with another second one, where that is your which is your the electrodialysis. In terms of electrodialysis here, where the ordinarily that the process dialysis we have there's a quite slow, and it can be made faster by applying an electric field. It is just if the dissolved substance that is in pure colloidal solutions is only an electrolyte. The process is named electrodialysis. The colloidal solution is placed in the bag of suitable membrane, while pure water is taken outside and electrodes are fitted in the compartment as shown, where the ions present in the colloidal solution migrate out to the oppositely charged electrode as well. For the same case, we will be going ahead and that we have to find out for the charging, that is your electrodialysis. So that is being representing here in the following diagram here. So this is here, this is from here inside it, this is the water is being inserted, and here it is one that is your anode, which is a plus node. Here it is minus, that is the another one is your, that is cathode, it is minus. From here it is coming out is your water plus electrolyte. So here this is the molecules we have is your salt particles, and the another we have is your, that is crystalloid, and this is your dialysing membrane. So this is what we have is known as electrodialysis. Now we'll term in the same cases we have to talk about the another one, and which is the another one we have to discuss is your ultrafiltration, that is the third one. In terms of ultrafiltration, we talk about it, and that is eventually that is important here. For the ultrafiltration here, that is, the ultrafiltration is the process of separating the colloidal particles from the solvent and soluble solutes that is present the colloidal solution by specially prepared filters, which are permeable to the all or substance except the colloidal particles. Colloidal particles can pass through an ordinary filter paper because the pores are too large, and however the pores of filter paper that can be reduced in the size by that is your impregnating with colloidal, and that is a solution that to stop the flow of the colloidal particle as well. We are the same case that the usual the colloidal that is 4% solutions of that we have is your colloidal particles and cellulose in the mixtures of alcohol and ether as well. An ultra-filter paper that may be prepared by soaking the filter paper in the colloidal solution and hardening by the formaldehyde and then finally drying it up. And after that we have to discuss here. So on the same cases for the ultrafiltration here, and on the same does that using by using the ultrafilter paper that the colloidal particles are separated from the rest of the material, and ultrafiltration is a slow process, and to speed up the process pressures or the suctions is applied here, and that the colloidal particles left on the ultrafilter paper and are then stirred with the fresh dispersion medium, which is solvent, that to get a pure colloidal solution as well. Now we'll discuss about the another one, which is the properties of colloidal solution. So that is to be as follows. Properties of colloidal solution. So in terms of properties of colloidal solution that we have to talk about it, where various properties are exhibited by the colloidal solution that we are discussed below. The first property we have is your colligative that is properties. So qualitative properties here that the colloidal particles being bigger aggregates that the number of particles in a colloidal solution is comparatively the small as compared to the true solution, and hence the value of the qualitative properties: osmotic pressures, lowering in vapor pressure, depressions in freezing point, and elevation in boiling point, that are of small order as compared to the values that shown by the true solutions at same concentration as well. The second we have is your Tyndall effect. In terms of Tyndall effect, that if the homogeneous solution that plays in a dark is observed in the directions of light, it appears clear, and if the observed from the direction at right angle to the direction of the light beam, it appears perfectly dark, and colloidal solutions viewed here in the same way that also appears reasonably clear and translucent by the transmitted light, but they show a mild to strong that is your opalescence, and when viewed at right angles to the passage of light, that is the path of the beam is illuminated by the blemish light as well. This effect was first observed by the Faraday and later studied in the detail by the Tyndall, and the termed as Tyndall effect as well. The bright cone of that light is known as your Tyndall cone here. In the same cases that the Tyndall effect is due to the fact that the colloidal particles scatter light in all the directions in space, and this scattering of light illuminates the path of the beam in the colloidal dispersion as well. The Tyndall effect that can be observed during the projections of pictures in a cinema hall due to scattering of light by dust and smoke particles present there. Tyndall effect is observed only when the following two conditions are satisfied. On the same case, I will just tell you for the Tyndall cone that they had make you is about the scattering of light while seeing through the microscope that we have. So I just represent that Tyndall effect diagram so that you will be get to know about it in a detail, and eventually you will understand about it as well. So here we have a diagram here. This is a lamp or light source, you can say that. Okay, this is a light source. So it will form, this is mirror, then it converged, this is a beaker, it disappeared here as well, it will move in a different directions, and that is we have, this is a microscope. We can just you can just imagine it out. Okay, so this is a microscope, and here it is a eye, we are seeing it. Okay, so this is how we will see it, and this has been the light source as I told you. This is a Tyndall cone, and this is the scattering light. This is microscope, and this is of course eye. This is the solution which we have. This is the solution is colloidal solution, and this whole is known as Tyndall effect. Okay, so where that Tyndall effect is observed only when the following two conditions are satisfied, that as I told you before, and only. The first condition is that the diameter of the dispersed particle is not much smaller than that the wavelength of the light which is used, and the second is that the refractive index of the dispersed phase and the dispersion medium differ greatly in magnitude as well. That even though we have to discuss here. Now we'll go ahead further, which we have to talk about it, and that is the another one in terms of it, in the terms of this only, and that is for the Tyndall effect here. In terms of Tyndall effect, that is used to distinguish between a colloidal and a true solution, which is your that is Montley in 1903 that used the Tyndall effect to set up the apparatus known as ultra microscope. An intense beam of light is focused on the colloidal solution that contained in the glass vessels, where the focus of the light is then observed with a microscopic and a right angle that for the beam, and individual colloidal particles appears as bright stars, that is against as a dark background. Ultramicroscopic does not renders the actual colloidal particle visible but only observe the light scattered by them. The ultramicroscopic does not provide any information about the size of any shape of the colloidal particles as well. The third we'll talk about it is that is the color here. Is your color. In terms of color here, that is that the color of the colloidal solution that depends on the wavelength of light scattered by the dispersed particle, and the wavelength of the further that depends on the size and the nature of the particle, where that the color of the colloidal solution also changes with the manner in which the observer receives the light. For example, a mixture of milk and water appears blue when viewed by the reflected light and red when viewed by the transmitted light. Finest gold salt is red in color. As that the size of particles increases, it appears purple, then blue, and finally golden here. Now we'll talk about the fourth one, which is your Brownian moment here. We'll talk about the another one, that is the fourth category we have to talk about it. That is your, as I told you, Brownian moment. In terms of Brownian movement here, when the colloidal solutions that are viewed under a powerful ultra microscope, then the colloidal particles appears to be a state of continuous zigzag motions all over the field of view. This motion was first observed by the British, that is botanist Robert Brown, and is known as the Brownian movement. This motion is independent of the nature of the colloidal but depend on the size of the particles and viscosity of the solution. Smaller the size and the lesser the viscosity, faster the motion as well. That the Brownian movement here, that has been explained to be that due to the unbalanced bombardment of the particles by the movement has been a string effect which does not permit the particles to settle and thus is responsible for the stability of the salts as well. Now we'll talk about the fifth one. In the terms of Brownian movement here, yeah, we can represent that as well, and in a zigzag manner that it should be represented. So it would be like this. So it will represent it like this only. So this has been representing with the directions as well. Then it will be coming towards it, that we have here as well. This is a Brownian moment. Now we'll go ahead with another one, which is we have to discuss about it, and that is the fifth one, and that is we have as follows, that is the charge on colloidal particles. Charge on colloidal particles. In this, they are that the colloidal particles always carry an electric charge, and the nature of this charge is the same as on all the particles in a given colloidal solution and may be either positive or negative. And a list of some common salts with the natures of charge of their particles is to be given here. Where in terms of positive charged salts and negatively charged salts, we talk about it. In the same case, that the hydrated metallic oxide we have, which is example is Al2O3 XH2O, that is CrO3 XH2O, and Fe2O3 and then XH2O, that is these were the hydrated metallic oxides. In terms of negative charge salts, that metals we have copper, silvers and gold salts as well. The second is your basic dyes stuffs, example like methylene blue salt, and for the negative charge we have metallic sulfides, that is As2, S2, Sb2, S3 and CdS salts as well. In terms of positively charged salts, the hemoglobin that we have, that is consistent in blood, and acid diastuffs, example is your eosins, Congo red salts as well. In terms of positive charge here, which we'll talk about it, that is oxide, and that example is TiO2 salts, and for the negatively charged, that salts of the starch, gums, gelatin, clay and charcoal, etc. that we have. Now in the same cases we will go ahead further, that we will discuss here as well. In the same case, where the charge on the salt's particles is due to one or more reasons, that is due to the electron that captured by a salt particle during the electrodispersions of metals, due to the preferential absorptions of ions from a solution, and or due to a combination of electrical double layer as well. Preferential absorptions of ions is the most accepted reason, and the salt particles require positive or negative charge by preferential absorption of positive or negative ions. When two or more ions are present in the dispersion medium, then the preferential absorptions of the ions common to the colloidal particle usually take place. This can be explained by taking an example, following example. The first we have here which is when silver nitrate solution is added to a potassium iodide solution, the precipitate silver iodide absorb iodide ion from the dispersions medium and negatively charged colloidal solution results. However, when Ki solution is added to AgNO3 solution, positively charged solution that results due to the adsorptions of Ag plus ions from the dispersion medium as well. It is AgI by I, so that is will have your negatively charged, and AgI by Aga plus, that's positively charged as well. In the same case, for if FeCl3 is added to an excess of hot water and a positively charged salts of a hydrated ferric oxide is formed due to the adsorptions of Fe3 plus ions. So however, when ferric chloride is added to an OH, a negatively charged salt is obtained with adsorption of OH ions as well. Having acquired a positive or a negative charge by a selective adsorption on the surface of colloidal particle as stated above, this layer will drag the counter ions from the minimum, forming a second layer that to be shown here. Where in the same cases that the combinations of the two layers of opposite charge and around the colloidal particle is called the Helmholtz electrical double layer, where according to the modern view, the first layer of the ions is firmly held in the termed fixed layer, while the second layer is a mobile, which is termed diffused layer, and since separations of charge is a seat of potential and the charge of opposite signs on the fixed and diffused parts of the double layer, that results in the difference in potential between these layers, and this potential difference between the fixed layer and the diffused layer of opposite charge is called as electrokinetic potential or zeta potential as well. The presence of equal and similar charges on colloidal particle is largely responsible in providing stability of the colloidal solution, because the repulsive forces between the charged particles having the same charge that prevent them from the coalescing and or aggregating when they come closer to one another. So we talk about the sixth one, which is your electrophoresis. Electrophoresis, yeah. In this, that the existence of charge on colloidal particles is confirmed by electrophoresis experiment, when electric potential is applied across two platinum electrodes that dipping in a colloidal solution, the colloidal particles moves towards one or the other solution, and the colloidal particles move towards one or other electrode. That the movement of colloidal particles under an applied electric potential is called electrophoresis as well, where positively charged particles moves towards the cathode, while in the same cases for the negatively, if I am going ahead, that is the negatively particles that moves towards that is the anode as well. And this can be, that is demonstrated by the following experiment that we did here, that is in the difference of electrophoresis as well. When here, so just I will draw for you all so that you will get to know about it, what experiment, for what experiment we are talking about it. So this is an experiment like such as here that I will be drawing it. So here it is. This is your anode. This is cathode. This is negative. This is cathode, which is positive. Okay. And there is a tube. This is in here. This is a stopper. Stop clock. Okay, and this is your, the moment I will just show it. So here this is your the initial level. This is your water, which is dispersion medium. This is your colloidal solution. Electrophoresis, that is we have representing here. So when electrophoresis, that is the movement of the particles prevented by some suitable means, and it is observed that the dispersions of medium that begins to move in an clock field. This phenomena is termed as electroosmosis, that is, and coagulations or the precipitation, we'll talk about that, is the seventh one here. Coagulation or precipitation. In coagulation and precipitation, where the stability of the lyophilic salts is due to the presence of the charge or the colloidal particles, and if somehow that the charge is removed, and the particles will come nearer to each other and to form the aggregate or a coagulate and settle down under the force of gravity as well. Where in that same case, the process of settling of colloidal particles by the coagulations or precipitations of the salts as well. With the coagulation of hydrophobic salts that can be carried out in the following ways, and we'll talk about that as the coagulation. In terms of coagulation, there is a part. So there we'll talk about the first part, which is your Bielectrophoresis. By electrophoresis here, that is in terms of electrophoresis we had talked about it, and but I will just tell you about it as well. So the colloidal particles that moves towards the opposite, that is your opposite charge electrode, that get discharged and precipitated as well. We'll talk about the second one, which is in terms of the coagulation that has been representing here, and eventually we have to talk about it. So the second we have is your by mixing two oppositely charged salts. By mixing two oppositely charged salts, that we have to talk about it. In the same cases here, that is the oppositely charged salts, when mixed in almost equal proportions and neutralizes their charges, and gel partially or completely precipitated. Mixing of hydrated ferric oxide, which is positive salts, and arsenious salt, that is negative salts, bring in the precipitation form, and this type of coagulation is called a mutual coagulation as well. We'll talk about the third one which we have, and that is your by boiling. In by boiling here, that is when the salt is boiled, that the adsorbed layer is disturbed due to the increased collision with the molecules of dispersion medium, and this reduces the charge on the particles and ultimately led to the settling down in the form of the precipitate as well. We'll talk about the fourth one, which is by persistent dialysis. By persistent dialysis. And by persistent dialysis, on prolonged dialysis, that traces of the electrolyte present in the salts that are removed almost completely, and the colloids become unstable and ultimately coagulate as well. We talk about the fifth one we have is your by addition of electrolyte. By the addition of electrolyte. In terms of by addition of electrolyte, we'll talk about it here. That is the by addition of electrolyte, when the excess of electrolyte is added and that the colloidal particles are precipitated. The reason is that the colloidal interact with ions and carrying charge opposite to the present and themselves. This causes neutralization leading to their coagulation, and that the ion responsible for neutralization of charge of the particles, that called the coagulation ion, and a negative charge causes the precipitate of positively charged salts, and vice versa. It has been observed that generally the greater the valence and that fluctuating ions added, The greater is the power to cause precipitation, and this is known as Hardy's Stricture that issues law, and the calculations of negative source and flocculating the power in the order of AM. 3 plus is greater than BA 2 plus and here. Similarly, the coagulation of positive salts from the fluctuating position is in the order of which we have as your FeCN 6 4 minus is greater than PO4 2 minus, 3 minus is greater than SO4 2 minus, and Cn minus here. So that the minimum concentrations of an electrolyte is in millimoles that per liter required to cause the precipitation of the salts in 2 hours is called coagulation value, and the smaller the quantity needed and the higher that will be the coagulation power of an ion as well. Now we'll talk about another one which will in terms of it, that is we have to talk about it, and which is that is your the coagulation of lyophilic salts here. Coagulations of lyophilic salts. Coagulation of lyophilic salts here, that we have to talk about it. So let's go ahead for that further as well. So in the same cases for the coagulations of lyophilic salts here, there are the two factors which are responsible for the stability of the lyophilic salts, and these factors are of the charge and the solvations of colloidal particles. When these two factors are removed, a lyophilic salt that can be coagulated, and this is done by adding an electrolyte and that by adding a suitable solvent. When solvents such as alcohol and acetone are added to the hydrophilic salts and the dehydrations of dispersed phase occurs. Under this condition, a small quantity of electrolyte can bring about the coagulation here. We'll talk about another one, which is the protections of colloid here. Protection of colloids. So in terms of protections of colloid here, that is the lyophilic salts are more stable than the lyophobic salts, and this is due to the fact that the lyophilic colloids are extensively solvated, that is the colloidal particles are covered by the sheath of the liquid in which they are dispersed. Lyophilic colloids have a unique property of protecting the lyophobic colloids, and when the lyophilic salts is added to a lyophobic salt, then the lyophilic particles form a layer around the lyophobic particles and thus protect the latter from electrolyte, and lyophilic colloids used for this purpose are called protective colloids as well. We'll talk about the another one that we have to talk about it, and eventually that is also an important one as well, that is your emulsion. In terms of emulsions here, and in the same cases that we have to talk about it. For the emulsion, that there are the liquid colloidal systems, liquid colloidal system, and the dispersions of blindly divided droplet into the another liquid if the mixtures of the two immiscible or particles miscible liquid is shaken, or of course dispersions of one liquid in the other is obtained, which is called emulsion. Generally, one of the two liquid is in water, and there are the two types of emulsions here. The first emulsion we have is your oil dispersed in water, which is your oil water type. The second we have is water dispersed in oil, which is WO type. In the same cases, in the first system here, that the water act as a dispersion medium. An example of this type of emulsions are milk and vanishing cream. And in milk, liquid or fat is dispersed in water. In the second system, oil act as a dispersion medium. And common example of this type are butter and cream as well. In the same cases, we can see that the cold cream as well. And the another we can see that emulsions of that is we have that the emulsions of oil and water that are unstable, and sometimes they separate into layers and standing. And for stabilizations of emulsions here, so onto the same cases, we can say that here that the emulsions of oil and water that are stable, and sometimes they are separate into the layers on standing, as I told you. And for that stabilization of an emulsions, and a third component called emulsifying agent is usually added, where emulsifying agent forms an interfacial film between suspended particles and the medium. The particles emulsions agents for oil and water emulsions that are protein, gums, natural and synthetic soaps, etc. And for the water and that is we have water dispersed in oil here, that is heavy protein, gums, natural and synthetic soaps. And water oil, that is heavy metal salts of fatty acids, that is long chain alcohol and lampblack, etc. Emulsions that can be diluted with any amount of the dispersions medium. On the other hand, the dispersed liquid which mixed forms in a separate layer, and the droplets in the emulsions of often negatively charged, and that can be precipitated by electrolysis. And they also show the Brownie Moment and the Tyndall effect, an emulsion that can be broken into the constituent particle liquid by heating, freezing and centrifuging, etc. We'll go ahead with another one which we have to talk about it, that is colloids around us. In terms of colloid around us that we have to talk about it, where in the most of the substances we come across in our daily life are colloids. The meals we eat, the clothes we wear, the wooden furniture we use like house we live, and the newspaper we read, and are largely composed of colloids as well. And the same casing for our following are the interesting and noteworthy examples of colloid as well. The first we have is your blue color of the sky here, that is in the terms of blue color of the sky. So yes, we'll go ahead, and that is the blue color of sky, that is your the dust particles around along with the water that is suspended and scatter blue light which reaches our eyes, and the sky looks like blue color here, and that we use here. The second we have is your the frost and mist and rain as well. The fog, mist and rain, that is that when a large mass of air containing the dust particle is cooled below its dew points, and the moisture from the air that condenses on the surfaces of these particles, that forming the fine droplet that condenses on the that is on the surfaces of the particles, that forming the fine drops. And these droplets being colloidal in nature and continue in float in the air, and that form of mist or fog. Colloids are aerosols and having a small droplets of water that are suspended in air on account of the condensation, that is the upper atmosphere, and the colloidal droplets of water that grow bigger and bigger in size till they come down in the form of rain. Sometimes the rainfall occurs when two oppositely charged clouds meet here. It is possible to cause artificial rain by throwing the electrified sand and or sprays salts that carry charge positively, and one can be a cloud and an green as well. Now we'll go ahead third one, which is the food, which we have food articles like milk, butter, halwa, ice cream and fruit juices, that etc. are the colloids in one form or the other. Another we can say that the blood, it is a colloidal solution of an aluminide substances, and that the styptic actions of alum and ferric chloride solution is due to the coagulation of blood forming clot that which we have stops further bleeding as well. The another we have is your soils. In terms of soils, the fertile soils are colloidals in nature, in which the humus act as that is a protective chloride, and on account of the colloidal nature, soils absorbs moistures and nourishing the material as well. The next and the last, the sixth one we have is the formations of delta. So river water is a colloidal solutions of clay, and that sea water contains numbers of electrolyte, and when river water meets the sea water, the electrolytes present in the sea water coagulates and colloidal solutions of clay, resulting in the depositions of the formations of delta as well. Now we'll discuss about the applications here. In terms of application, the colloidals are very widely distributed, used in the industry. The following some examples are: the first is electrical precipitation of smoke. Electrical precipitations of smoke. That is, the smoke is a colloidal solutions of solid particles such as carbon and arsenic compound, dust, etc., and air. That the smoke before it comes out from the chimney and is led through a chamber containing the plates having a charge opposite to that carried by the smoke particles. Particles on coming in contact with them, that the plates loses their charges and get precipitated. The particles then settle down on the floor of the chamber, and the precipitator is called the quartile, that is precipitator as well. Now we'll talk about the second one, which is purification of drinking water. So purification of drinking water here, that the water obtained like natural sources often contain the suspended impurities. Alum is added to such water to coagulate the suspended impurities and make water fit for drinking purposes as well. The third we have is your medicines. In terms of medicines, that most of the medicines are the colloidal in nature. For example, that is your alcohol is a silver salt that is used for the eye lotions as well. Colloidal antimony is used in curing the Kala-Azar's. Colloidal cold is used for the intramuscular injections, and milk of magnesia, that an emulsion is used for the stomach disorder. And colloidal medicines are more effective to become they that have a large surface area, and they are easily that is assimilated as well. We'll talk about the fourth one, which is your tanning. In terms of tanning here, that is, the animal hides are colloidal, that in nature, and which hide which has a positively charged particle that is soaked in tannin, and which contains the negatively charged colloidal particles, and that is mutual coagulation take place. This results in hardening of leather, and this process is termed as tanning. Chromium salts are also used in the place of tannin as well. We'll talk about the fifth one, which is the cleansing action of soap and detergent. And before starting with this, we have a rubber industry as well. Talk about rubber industry. So in terms of rubber industry, that latex is colloidal solutions of rubber particles which are negatively charged, and rubber is obtained by coagulation by latex as well. We'll talk about the another one, which is the sixth one here, and that is the cleansing action of soap and detergent. Cleansing action of soap and detergent. So in the same cases, for that, this has already been described in that we had done here. Now we have a photographic plates and films. That is the seventh one. Photographic plates and film. In this, that the photographic plates and films are prepared by coating and emulsions of the light sensitive silver bromide in gelatin over the glass plates and the celluloid film as well. The another and the last is your eighth one, which is industrial product. In that, paints, inks, synthetic plastic, rubber, and graphite, lubricants, cements, etc. are also the colloidal solutions as well. Then after that, we'll give you as a homework for the insights question, that is what modification that can you suggest to the Hardy schedules law. And another is, why is it essential to wash the precipitate with water before estimating its quantity as well. So in the same last, we'll talk about the summary. You can say that about what we had done in these last classes here, which here adsorption is a phenomenon of attracting and retaining the molecules of the substance on the surface of solid, that are resulting into the higher concentrations on the surfaces than in the bulk. And the substance that adsorb is known as adsorbate, and the substance on which the absorption takes place is called adsorbent as well. In phytoabsorptions, adsorbs is held as an adsorbent by the weak van der Waals forces, and as in chemisorption, the adsorbate is held by the adsorbent by strong chemical bond, and almost all solids are absorbed gases here. The extent of adsorptions of the gas on a liquid that depends upon the nature of the gas and the nature of solids, surface area of the solids, and the pressures of gas and temperature of gas. The relationship between the extent of adsorption, that pressures of a gas at constant temperature, is known as adsorption isomerism here. Isotherms, and a catalyst is a substance which enhances the rate of the chemical reaction without itself that getting used up in the reaction, and the phenomena used catalyst is known as catalysis here. Where homogeneous catalysis, and the catalysis is in the same phase and as our reactant, and heterogeneous catalyst is the catalyst is in the different phase from that of the reactant as well. In the same cases, the colloidal solutions are intermediate between the two solutions and the suspension. The size of the colloidal particle ranges from 1 to 1000 nm. The colloidal system consists of two phases, where the dispersed phase and the dispersion medium. Colloidal systems are classified in three ways, that is depending upon the physical state of the dispersed phase and the dispersion medium, where the nature of the interactions between the dispersed phase and the dispersion medium, nature of particles of dispersed phase, the colloidal system that shows interesting optical, mechanical and electrical properties as well. Where the process of changing the colloidal particle is in the salt into the insoluble precipitate by additions of some suitable electrolysis is known as coagulation, emulsions and colloidal systems as well. In the same cases in which both the dispersed phase and the dispersion medium are liquids, and these can be of in which that both dispersed phase and the dispersion mediums are liquid, and these can be of like oil in water type, water in oil type. The process of making the emulsions is known as emulsification, and to stabilize an emulsion, an emulsion agent and emulsifiers that is added here, and that soaps and detergents are most frequently used in emulsions, and colloids that several application in industry as well as in daily life as well. In terms of it, we'll have a last few questions that you have to do by your own side, that we even though had discussed in these classes here. The first is to distinguish between the meaning of the term adsorption and absorptions. Give one example each. What is the difference between physiosorptions and chemisorption? Give reasons why finely divided substance is more effective and adsorbent. Next is, what are the factors that which influence the adsorptions of gases on solid? What is adsorption isotherism, and explain the privileged adsorption isotherism. What do you understand by the activation of adsorbent? How is it achieved? What role does adsorption plays in a heterogeneous catalyst? Why is adsorption always exothermic? How are the colloidal solutions classified on the basis of the physical state of the dispersed phase and the dispersion medium? Discuss the effect of the pressures and temperature of the adsorptions of gases on solids. What are the lyophilic and lyophobic salts? Give one example of each. Why are hydrophobic salts easily coagulated? What is the difference between the multimolecular and the macromolecular colloidal? Give one example of each, and how are associated colloids from these two types of colloids? What are enzymes? Write in brief and mechanism of enzyme catalyst. How are colloids classified on the basis of physical states of component, nature of dispersed phase, and interaction between the dispersed phase and dispersion medium? Explain what is observed when a beam of light is passed through the colloidal salts, and electrolyte NaCl is added. to the hydrated ferric oxide, and an electric current is passed through a colloidal salt. What is emulsion? What are their different types? We give an example of each. How are the emulsifiers stabilize emulsion? Name two emulsifiers. Action the stroke is due to the emulsification and vessel formation. Comment. You have to comment on. Give four examples of heterogeneous catalysts. 19th question. 20th. What do you mean by the activity and selectivity of the catalyst? Describe some features of catalysis by the zeolite. What is the shape of the selective catalyst? Explain the following terms like electrophoresis, coagulation, dialysis, Tyndall effect. Give four uses of emulsion. What are the missiles? Given examples of missile system. Explain the terms of the suitable example like aerosol, alcohol, and hydrosol. And the 77th question we have to talk about it. Comment on the statement that the colloid is not a substance but a state of substance as well. So here we'll end up with, and it's a huge request from my side to all the viewers to please go through with the subscribe button and please like, share and subscribe to our channel so that many and maximum people can get the information at once, and even you can also enjoy the video as well. Other than chemistry, if I'm talking about, so yes, we had completed sociology and software engineering as well. Other than that, we are dealing with the quantitative aptitude, wherein the arithmetical ability we had started with, and in that we had done your operations on numbers, LCM and SCF of numbers, decimal fractions, and simplification and square roots and cube roots, and now we had started with averages as well. In terms of reasoning, where we had completed the verbal reasoning, which is general mental ability, and the logic reasoning. In non-verbal reasoning, we had completed series, analogy, classification, analytical reasoning, mirror image, water image, embedded figure, and completion of incomplete patterns, and now we had started with the pattern, figure matrix as well. After that, we talk about for the chemistry. There we had completed unit 1, which is the solid state, where we had covered up the general characteristics of solid state, amorphous and crystalline solid, classification of crystalline solid, crystal lattice and unit cells, numbers of atoms in unit cells, closed packed structures, packing efficiency calculation involving the unit cell dimensions, imperfections in solid, electrical properties, magnetic properties as well. The second is your unit 2, which is solution, that is type of solution, expressing the concentration of solution, solubility, vapor pressures of the liquid solution, ideal and non-ideal solution, colligative property of determinations of molar masses, abnormal molar masses as well. Unit 3, which we have to cover up, is your electrochemistry, where electrochemical cells, galvanic cells, Nernst equation, conductive of electrolytic solution, electrolyte cells and electrolysis, batteries, fuel cells, and that is corrosion as well. Unit 4, which we had covered up with chemical kinetics, where we had completed the rate of the chemical reaction, factors influencing the rate of reaction, integrated rate equation, pseudo first order reaction, temperature dependence on the rate of the reaction, collision, theory of the chemical reaction. Unit 5 is surface chemistry, which is we have to cover up the adsorption, catalyst, colloids, classification of colloids, emulsion, colloid anomalous. Unit 6th we have we'll start in the next coming class, which is general principles and processes of isolations of element, which is that is occurrence of metals, concentrations of ores, extraction of crude metal and concentrated ore, thermodynamic principle of metallurgy, electrochemical principle of metallurgy, oxidation, reduction, refining, uses of aluminum, copper, zinc and iron. Unit 7 is the P block element, where we have to discuss about the group 15 element, dinitrogen, ammonium, oxides of nitrogen, nitric acid, phosphorus, allotrophic forms, phosphine, phosphorus, halides and oxides of phosphorus. Group 16 element, dinitrogen, dioxygen, simple oxides, ozone, sulfur, allotrophic forms, sulfur dioxide, oxoacids of sulfur, sulfuric acid. Group 17 element, chlorine, hydrogen chloride, oxoacids of halogens, interhalogens compound, and group 18 elements. Unit 8 is the D and F block element, positions in the periodic table, electronic configurations of the D block element, general principal properties of the transition element of D block, some important compounds of transition element, the lanthanides, actinides, some application of D and F block element as well. Unit 9, which is coordination compound, oneness theory of the coordination compound, definition of some important terms pertaining to the coordination compound, nomenclature of coordination compound, isomerism of the coordination compound, bonding in the coordination compound, bonding in metal carbonalysis, stability of the coordination compound, importance of application of coordination compound as well. That we have to end up here. First of all, it's a huge request from my side to all the viewers to please give a go through the subscribe button and please like, share and subscribe to our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. And the request is that you can just go ahead with subscribe button and you can just go ahead with the like and share and subscribe to our channel. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.